Let's take a look at how to use the empirical rule in some of these problems. Here's an example of a problem. It says the blood platelet counts of a group of women have a bell-shaped distribution, so we know it's got normal distribution. We've got a mean of 250.3. So X bar is 250.3. And a standard deviation of 65.6. S is 65.6. Using the empirical rule, find each approximate percentage below. What is the approximate percentage of women with platelet counts within 2 standard deviations, or between 19.1 and 381.5? Now this states that that's 2 standard deviations, but we can check if we had X bar plus 2 standard deviations, that would be 250.3 plus 2 times 65.6. 2 standard deviations is 131.2, so 250.3 plus 131.2, which is going to be 381.5, which is exactly what they've got here. So I'm going to trust that this is also 2 standard deviations below the mean. In other words, this would be 250.3 minus 131.2, 2 standard deviations. So we don't have to do any real calculating. We already know that if it's within 2 standard deviations, so here is the 250.3, 1 standard deviation, 2 standard deviations. This is 381.5. 1 standard deviation, 2 standard deviations. This is going to be 119.1. The distance between these all is 65.6. And we already know from the empirical rule, 68, 95, 99.7. that there's 68% between plus and minus 1 standard deviation, 95 between plus and minus 2, that's this. So this answer is going to be 95%. Now let me get rid of some of this. In the second part of this problem, they want to know what percentage of women in this group have platelet counts between 184.7 and 315.9. Now, is that going to be 1 standard deviation up? Well, let's check. The difference between 315.9 and 250.3 is 65.6. So this is 1 standard deviation up. This would be 315.9. We can double check. If I take the mean 250.3 and I subtract 1 standard deviation, I get 184.8, sorry, 0.7, actually. So that and that. So these turn out to be 1 standard deviation up and 1 standard deviation down. In a case like this, if you're not sure, get the difference between the mean and this number, and then divide that difference by the standard deviation to see how many standard deviations above or below the mean you've got. This is X plus and minus 1 standard deviation, and that's going to be at 68%. Nice work.